So what do we think? Should we get going?
I mean, if you like, we only got 3 other people in here right now.
I know. I was wondering if we should, yeah. Oh, people are starting to pile in here. Here we go. Yeah, people are starting to come in.
Yeah, I think we can go ahead. I resent the reminder email, so.
Okay. All right.
Fantastic. All right. Well, then we'll get going. I believe this is, session 59. So this is the 59th office hours that we've had. So welcome everybody. This is awesome. Today we're going to look at some new KineFX material and some research that Owen has been doing for us on KineFX. He's going to do a little demo, and then we can open up for questions about anything that you guys would like, KineFX or otherwise. And then I also want to mention real quick that this is Owen's last office hours session that he'll have with us. Owen has been an incredible asset for us in the intern department, creating courses, doing research in KineFX, helping us out with office hours, doing node videos, building courses on the LMS, just been incredibly talented and incredibly useful for us. And we really appreciated his time. But nonetheless, we are giving Owen away to Sucker Punch. So Owen has a new job, and that's awesome. So right from the internship into industry, which is how the majority of our interns have kind of gone. So this is also a little bribe. If you have excellent students that you think will be good candidates for interns, please have them go to the intern application page and fill out the application. We're always looking for good intern possibilities. But Owen, I will, before I turn it over to you for your demo, I just want to give it if anything you want to say to anybody as a big farewell.
I don't know. It's been really fantastic working with everyone here at SideFX and working in office hours every couple of weeks, getting to talk with professors from across the world. It's been absolutely amazing, and I hope I can do something similar again in the future, interacting with so many people across the world and learning from so many people as well. Yeah.
Awesome. Yeah, well, we definitely would welcome your skill set back at any point. Cool. Well, before we get to the demo, I know Sam had something that she wanted to mention as well. So Sam, I'll pass it over to you.
Thank you. I'm just going to share my screen for a second, if you can see that. I just wanted to make a quick announcement about SIGGRAPH this year. So the SIGGRAPH 2021 Computer Animation Festival Electronic Theater, long name, is currently accepting submissions at no cost through March 23rd. So there's about a month left. We hope you'll consider sharing your work as part of this important festival, a qualifier for the Best Animated Short Film Academy Award. Each year, hundreds of your peers in computer graphics and interactive techniques contribute scientific innovations, technical achievements, and artistic accomplishments. What results is an unparalleled collaborative experience that is one of the world's largest and most influential events at the intersection of art, science, and technology. So I'm going to share a link in the chat. And if anybody is watching this in the recording and would like the link, please just contact education@sidefx.com, and I will share that with you. So thank you.
Awesome. Yeah, that's cool. Everybody misses travel, of course, and the big conferences and seeing everybody, but the electronic theater is always something I make every year. It's always impressive. It's an excellent way to showcase student work and promote your school as well. So very, very cool. Thank you, Sam. Okay, well, I'm going to jump right into it then and pass it over to Owen. Today, Owen, you might just want to tell everybody kind of what we're doing. We're kind of bridging the gap between character effects and KineFX, and we're going to do some neato stuff, but I'll pass it over to you and you can take it over from there. So take it away.
Sure. All right, so first things first, right after the last office hours, we released a new course for KineFX in regards to animation blending and retargeting and animation editing and whatnot. It's 11.1 animation with KineFX. Some things John and I had discussed for future plans, depending on different things. We're mainly focused around Vellum with KineFX. And we were going to do a little mini course, but since I'm leaving to go work at Sucker Punch, we're going to do this office hours instead, which will have a quick rundown kind of the things I've been exploring for KineFX and Vellum. And this will be the documentation on that before I leave. Kind of want to doing a Louise Cruel saying goodbye and doing one last tutorial.
That's right. Yeah, he did the live link thing with all the character stuff and was like, "I'm out." Mic drop.
Yeah. Yep. So yeah, let's just get started. I have 3 different example things that I'm going to show, and then one that I will walk through, since 2 of them are pretty simple if you've done anything with Vellum before. I won't be covering too much of the character retargeting and stuff like that. I'm just going to take different things in this blank Houdini scene when we start to walk through a tutorial or through this example in a second. I already have the retargeting set up, and if you want to know how to do retargeting and whatnot, please check out the new course that I was just talking about. All right. So the first thing that you can do pretty easily, just like with any other animated mesh and Vellum setup, you can attach different cloth and whatnot to your animated character and have it run just fine. Here's just a very simple Vellum setup where I have a grid that is a cape, quote unquote, and then I just have it attached to Eric here while he's being retargeted. And then he is also the collision geometry, as we can see here, when his foot is back. Just like and that's very simple for a Vellum setup. Very easy, and you can merge it together to see them playing at the same time. I didn't change anything special for the different parameters, but once you start to dive more into the cloth simulation itself and set up the cloth, you can do anything you want with the cloth at that point. And it'll work just fine with your character. It's important to note that the bone deform output is what I'm using as the collision, since that is the geometry that's being moved around, and not any of the skeleton paths. And the bone deform is what's after animation on bones and whatnot. Perfect. The next thing is I'm going to jump over here actually to show a different just cloth simulation after bone animation and whatnot. Here we have, and I'm going to turn off template over here. Okay. So here we have my corporate guy from my tutorials. I'm just going to merge some things together. There we go. So we have my corporate here. And I had this coat for him that I modeled with him in this kind of A pose that I modeled him in. And I was thinking, well, if I've retargeted him to something, which is usually in some kind of T pose, as we can see here, then the cloth is no longer, then the jacket that I've modeled, this guy, is no longer in the shape of this T. So how do I set this jacket up properly to be played with a retargeted animation? And I'm sure there's a more elegant way of doing this, but my current solution looks a little bit like this. So we have our corporate guy without his jacket, and we retarget him onto the skeleton that we want, right? So now our skeleton is animating how we want to later on. I've offset the animation here on the import by 24 frames so that there's a little bit of dead space here, as we can see. And I will explain why in a second. The reason why I wanted some dead space is so that when I take this skeleton blend animation. The way I thought of how I can do it is I have this default A pose from the original rigged skeleton that does match the jacket, as we can see here. So I thought if I start the simulation on the A pose and then blend it to the first frame of the walk, then the jacket will stay on the character the way that I'm hoping it to be, rather than trying to change the mesh of the character and whatnot, or the jacket and match a T-pose and whatnot. I'm kind of starting the simulation on the A pose and then blending to an animation. Now I have two skeleton blend nodes here because the first one is to change to that first pose of the walk, as we can see here, rather than, as we can see on our import, this T pose. And I wanted to change to the first frame of the walk because I thought this jump from the T pose to the first frame of the walk would be too much change for the cloth sim to really work the way I'm hoping it to. So I grab the first frame using a time shift of the walk rather than when it's still in a T pose. And then I blend right back after that into the animation. And that's why I have two skeleton blend nodes there. Like I said, there's possibly a more elegant solution that you or your students might find for this. And another thing that is important to mention as well is that in the 11.1 course, we cover how to use retargeting when there is no T-pose on a character. So if there is no T-pose in the animation, like there is for this animation I've grabbed from Henry, then you don't have to worry about this double blend setup that I have here. But regardless, so we've gotten some nice little blend here to the first frame so that there's some time for the cloth to really attach to the character, the jacket to attach to the character, and then he starts this walk. So I've offset the animation a little bit for that. And when we just set up our jacket into a nice cloth simulation, and I didn't change any settings for anything, just a cloth simulation and a Vellum solver, and we check out the merged product, I didn't even set up any pinned points or anything. So we'll notice that the character starts to lose his jacket, but it still stays with him for a good amount of time. And you can see that once you set this up, you can then start to set up the jacket to be more realistic to how you're hoping it to be, or your students editing parameters and whatnot, so that it's the correct material and properties and it doesn't start to slip off his shoulders and whatnot. But I just wanted to show how if your students have something modeled in an A pose and they're retargeting to something like a T pose, a solution for that, since that was something I knew I ran into with a corporate, and that was something I wanted to cover in a Vellum course. Now, the final and cool thing that I will walk through after showing is this tail that we have here on Henry, on Eric rather, Eric's character here. I'm gonna turn on some points here. So we see we have this straight line and we have Eric being retargeted and animated. And if we play him, we get his tail dropping down. Now, the cool thing about this, and the reason it's different from the previous examples, is first we can see that there's a bit more. This is the cloth simulation from earlier. So let me just move that aside. Oops. Oh my gosh, never mind on that. We can see there's a bit more here. There's the setup of the tail, and then there's some Vellum simulation and some rig pose and some other stuff as well. But we can see that the tail is actually made out of joints, these points, rather than, we can see that these are the joints, these green points, rather than a cloth simulation that doesn't use KineFX at all. And we can use some KineFX tools like the spline solver to come in and edit the simulation, post simulation. As we can see here, we have just bent his animation, or one of the tail joints there a little bit using a spline solver. And you can start to do hand animation on top of simulated animation as well. So let's walk through that a little bit because it's really, really cool. I'm going to pull up just our Eric here. And the first thing that I'm going to do is start to set up that tail just using a line. And I'm going to put Eric on template. I'm going to make it in -Z so that it's pointing in kind of the direction we want. And I'm also going to move it to about where the animation is, just for this example. Just getting it into position. And that looks about right. That'll do just fine. And I'm going to increase the number of points because 2 is probably not enough for a tail. So let's just start with something like 12. That seems like a good point to start. Now to turn our line into some KineFX joints, we need name and transform attributes. And to enable those, I'm just going to use the rig doctor, which will fill in the name by default. And I'm going to change this to tail. And to get transforms, I'm just going to use initialize transforms. You can also use a reorient joints node to get transforms. But the rig doctor has that built into it. So I just like to use the rig doctor for these things. And we can see that we now have the little axes for our joints, and it's being displayed nicely. And I have Z pointing down the line. Perfect. So I'm just going to put a little null here just to mark my progress here. And we're just going to call these tail joints. Perfect. Now, the next thing that we want to do is, since these joints are completely separate from our joint chain over here, our characters joint chain, we want to set up a parent constraint so that our tail joints can follow, let's say, the pelvis, so that they can stay with our character's animation. So to do that, we're going to put down a rig op, and we're going to just hook up our different pieces of information, our different skeleton chains, which are coming from our retargeted skeleton chain and from our tail, right? And I'm going to name this parent constraint. Perfect. And I'm going to dive in. And we're going to just get the point transform of our tail 0 here by just clicking and dragging it in. We do some similar constraint setup and IK setups in the first KineFX course. So if this is unfamiliar workflow, please check out the first KineFX course as well. And oh my gosh, give me the pelvis. Okay. You can also just make your own nodes in here as well. Set point transform, or sorry, get point transform is what we want. There we go. And you can determine it. You can determine the name and the input. So you can change it to be by name if you know the name of it. So we need tail 0, as we saw here. And then we can also just copy that. And we know that second input is what we put our characters chain into. And we want this pelvis as such. So you can do a drag and drop. And if that's not working for you, as it wasn't for my pelvis for some reason, you can also just create nodes and determine the parameters yourself. Perfect. Now let's create that parent constraint node. And we're going to use the X form from our, I'm going to get this to be tail 0, just so we can visually see what we're doing, and pelvis rather than just get point transforms. So we're going to get the X form from our tail 0 and put it into the X form of our parent constraint. And then our parent constrainer, which is our pelvis, is going to go into the new parent slot. There's no previous parents for the tail, so we don't need to worry about those because we're not reparenting, we're just creating a new parent. And then we need to create a set point transforms. Oop, there you go, set point transform. It's important that you pay attention to and that your students pay attention to. If we look up set point transform, there's a set point transform, set point transforms. It can get very confusing if you've accidentally laid one or the other. Basically, you just you need to know if you're only editing one point like we are now with the tail versus multiple points, which we will do later in a second. So we just hook up our PT_num to be the same and our output X form. And now things should be working correctly. But I have missed something. Oh, no, I didn't miss something. It just moved things unexpectedly. Oops. So let me double check real quick my old file here. I may have just grabbed something wrong. Well, I'm not quite sure what's going wrong, but let me just pull up the other example real quick so that we can keep moving forward with things. As we can see here, we still have the get point transforms where we're getting tail 0 from by name and from the first input. We're getting pelvis. We're using a parent constraint, and then we're setting point transform. And as I was just walking through that, I think I know what I did wrong here. Is I'm going to update offset, and now things should be working properly. Yeah, there we go. I just forgot to click update offset. My bad, folks. Okay.
Good recovery. Good recovery.
Thank you. Thank you. All right. So now that we have, I apologize for my voice. Now that we have our tail following our character, we could start to set up the cloth simulation. So let's just create a Vellum hair, I think is what we want. Oops, sorry. That's not quite what I want. Vellum hair, since it's just a single point in lines kind of thing. And we'll set up our Vellum solver. There we go. Give it a second to process what we're doing. And we'll just take a look at what happens here. We'll notice that our points, our line, is being simulated and it just falls down. So we'll want to do a few things first. We're going to want to pin our tail 0 point. And if I can remember where that is. Oh, there we go, pin points. You can do it by name by just doing attribute name equals tail 0. And now we're pinning tail 0, as we can see here. But we notice that it's not moving with our animation right now. To fix that, you just need to click check match animation. And now when we move it, we see that the tail is moving with our character. And you can start to edit the the hair simulation however you see fit for your tail. But we want to see how this is affecting our joints, our rig, since we're trying to use this as a rigged tail joints versus just simulation. So I'm going to use a VisRig node here just to see how things are going. Now we see that as we scrub through this, our joints move as if they're being simulated, but they don't reorient the way that we're hoping for a joint system. Our Z does not continue to point down the axis or towards the next joint and towards the next joint, towards the next joint. So to solve this, we can use a solver real quick here. Oop, if tab will open for me. There we go. We'll just use a solver real quick where we'll reference the previous frame as our orientation node, as our to reorient our joints. So we're going to put down our reorient node here, reorient joints. And we're going to use our previous frame as our reference. And then we're going to use our input 0, which is our joints here, or input 1 rather. And since I had everything on default, I can leave everything default as well, since we're still aiming down the Z. But you'll want to make sure that if you or your students do this in the future, and they've decided to use a different axis to point down, like here we just have the Z pointing down the chain. If they use X or Y, you'll want to make sure that that's what they orient to in their reference, in their solver as well, or else things will go a little bit wonky. So I'll change my display flag to the reorient joints. And now if we scrub through, we can see that some things still go a little wonky. And I think it's because of what I just explained. I enabled to reference vectors, so I'm just going to disable that since I'm still just using defaults. And I don't want to confuse it. There we go. Now that the defaults are back to normal, we're getting the result that we're hoping for here, where the joints point down the way that we're hoping. Oops. And reorient in a way that we were expecting for a joint system. Now we'll notice as well, if I just allow this to play real quick and take a look at this last joint here, it kind of goes crazy no matter what we do. You can see it's different orientations frame by frame. And that's just because it has a very difficult time. There's nothing, there's no leaf node for it to really reorient to in the previous frame. So you can just blast this last joint away towards the end of your process and just not use it for the skinning process. So it won't affect your animation or simulation or anything like that. So at this point, if this is good enough simulation for whatever your project is, we could see there's some like weird jumpiness in there, and that just has to do with the cloth simulation. It was Henry recommended lowering the density even of the tail, just so it gets a little bit nicer, smoother animation there, and you could change the constraints and start to mess around with cloth however you see fit. I forgot where constraints are. Not change those. What am I looking for here? I'm looking for soft constraint versus, oh, it's right under the pin. There we go. So you can change that to soft and change the different types of pinning and whatnot. And we can see that we get a little bit better results where it's not jumping around as much. So you can start to change the cloth simulation how you want, or the hair simulation, the vellum simulation, however you see fit for the tail. And if this is good enough for whatever your purposes are, then you can start to, put this into your skin data. I wouldn't recommend just hooking it up into the bone deform, because you then have different number of joints in this bone deform versus the ones that you're plugging in. But if you create a new bone deform with the with a different system, or if you had just, let's say, our character here versus this joint chain, let's say it just already had the tail built in, which is probably what you'd want if your character had a tail. You'd probably just build it with the skeleton. Then you can just take those points and put them into your cloth simulation or vellum simulation, and then feed them back into the bone deform, and you'll get the expected outcome. With something like this, though, with the two different chains, I would make a different geometry for the tail and then skin it, and then have two bone deforms, kind of one for the tail and one for the character, and they'd be fine because they don't really collide with one another at all. So there'd be some clipping inside the mesh, but that would probably look fine depending on how the shot goes. But
Of course,
let's
the next
say
thing you would do would be cover it with hair and fur.
yeah, oh, there you go. There's another thing. Yeah.
So that would be a character solve with a vellum sim driving it, and then a hair groom on top of it, and then you'd simulate those hairs on top of that. So earlier
Oh
in the
my
chat,
gosh.
I mentioned like a layered simulation process.
Hmm.
That's exactly what we're doing here. Like, it's just a deeper dive into the character effects pipeline, really,
Yeah.
and KineFX to drive all of the other different, or not drive necessarily, but what would you say? Like it's weird because it's one thing being driven by
Yeah.
another and then re-driven on the opposite side, like on top of that. So it's kind of like layers in Photoshop, but it's layers of simulation on top of layers of simulation.
Yeah. I think it's just utilizing this all this now SOP information that we have, KineFX and Vellum and all this stuff that we have in SOPs, just utilizing it however we see fit. And it could be a very roundabout method where you start with hair simulation and then you go into KineFX, true just hardcore animation, and then you come back out and do some more hair simulation. It's doing whatever works.
Right.
Um,
We did have a question. I
yeah,
don't want to derail you too much.
sure,
It was
absolutely.
regarding the attribute VOP parent constraint that you made earlier.
Uh-huh. Yeah,
And is there, like, could you just go over that one more time because somebody missed it? And also, I want to say,
sure.
like, is that documented? Do you know if that's in, like, is that processed somewhere in like a help
Are
anywhere?
are
Or you-
constraints documented? Um, I don't know. I have not seen any documentation, but I also haven't looked for it. Um, So there's other kinds of constraints as well. There's an aim constraint, I think, or point at constraint. I can't quite remember what they're all called. But if we just look up some constraint here, yeah, look at constraint. So there's really only two kinds of constraint. There's a parent constraint and a look at constraint. But as far as I'm aware, I have not seen any documentation on these two things. They work very similarly to, if you're familiar with rigging in Maya, the parent constraint is similar to the, what's it called? I think it is called the parent constraint, where it takes, as we can see here, translate, rotate, and scale. And this is kind of like the coverall constraint. I think in Maya there is a scale constraint, there's a point constraint, which is transforms, and then there's a rotate constraint, which is rotates, which you can, if you only want one type of constraint, you can just click off the different kinds here. So this is kind of covers all of those things. And the only major kind of difference is that it needs to be set up in VEX, or in this VOP system. So the way we did that to cover it again, since that's what I think the question was, is that we have these nodes. We put down a get point transform, and we can determine it in a number of ways. We can get point numbers. The easiest way is to do by name and know which input you're trying to get a point from, and to then put your name in here. For instance, we have tail 0, which I knew was from the tail input, which is from input 1. So we have it by name, first input, and we have tail 0. You usually can also click and drag points in as such, and it'll create a get point transform. If there is multiple names over a point, as we can see here, we have tail 0 and tail 0 parentheses tail joints. It's usually the difference between a get point transform and a set point transform. As we can see here, we grabbed the different names and we got a get point transform, and we also got a set point transform. So that can be a little tricky for that user interface, is knowing the difference. Usually I just have to drag and guess, and that was a set point transform. So I just have to grab the other one to get the get point transform. But you can also do things by hand, as we were just saying. You can put the get point transform down, change it to be by name, whichever input you're trying to get a point from. And you can hover over just to see the name. Excuse me. Apologize for that. And then you can set things up from there. So we have our get point transforms now, our pelvis and our tail. And we know that our tail is what we want to be our child. So we're taking the X form of the tail and just putting it into the parent constraint X form, since those are the transforms we want to ultimately be editing. And we have our pelvis, which is what we want to be our new parent. So we're taking those transforms, those X forms, and putting them into the new parent node. And then we're taking the resulting transforms and putting them into the X forms of a set point transform node here. And we're also just taking our point number and plugging it into the point number as well, so that this set point transforms knows which point we're trying to change the transforms of. Did that help answer the question? I hope.
Yeah, I think that was right on with what we were trying to get at there. And I would point out too that like it might not be directly in the documentation, but you do go through that process in which course?
We go through setting up an IK solver in the first KineFX course, 11.0, where I do explain this drag in interface and the different placing of nodes and the different point numbers and X forms and that kind of stuff, but utilizing an IK solver versus a point constraint. But the concepts should be able to flow pretty fluidly between a parent constraint and a IK solver, just needing to hook up the different X forms in a different way, kind of thing.
Awesome. All right, cool. Thank you, sir. Sorry to derail you there, but yeah, great answer.
Absolutely. No problem at all. If there are any other questions, just feel free to stop me or even unmute yourself and feel free to ask. Yeah, this is an office hours after all. So
yeah, more laid back than a normal webinar.
Yeah.
That's our tagline: office hours, more laid back than a normal webinar.
Nice. So here we are back at the SOP level here, with the tail. The multiple points that we're seeing here is just because I have multiple things clicked and viewed and whatnot. But we got the tail flowing, and it's also reoriented the way that we were hoping, as we saw from the rig VOP. But let's say we just put this into a like a rig pose here. This is a lot of joints to be editing one at a time if we wanted to do any hand animation on top of our simulated animation. You know, it's just a lot of joints, as we can see. So we can utilize another solver, the spline solver, which is also in a rig VOP here. So let's put down a rig VOP. And I'm just going to dive in without hooking any inputs in right now. So we're going to be using a spline. Oops, sorry. There we go. Curve solver. My bad. It's not quite a spline solver, but we're going to be using this curve solver, which is very similar in appearance to the IK solver, since we're using points to as like guide points to edit other points. So we're going to take some parent points basically, and we're going to use them to edit our longer number of points here. So we can kind of slim down on the number of control points that we're using. To do that, I'm just going to copy our line up here, since we do need joints for this specific solve. And I'm just going to take this, I'm going to call these the skin joints now. There we go. And looking back at my documentation, I actually have this backwards, my bad. These are going to be our control joints, our sim joints, the ones that we can then use control or sim. These are going to be the things controlling the spline. And these guys are going to be our skin joints. And I'll show how this all combines in a second. So we have these skin joints, 12 points of them, and we're going to make them follow a curve that is determined by our simulation here. So I'm going to lessen the number of points on our simulation to just be something like 4, where these 4 points are going to go through our simulation as they are right now. And they themselves make a curve. These 4 points will make a curve. You can kind of imagine if there was like a Bezier curve going through these 4 points. That is what we're going to utilize to edit our 12 points, our skin joints that we want. So let's now put our simulated path here, these less numerous, these 4 points that are simulated, and our skin joints into our rig VOP here. And we'll dive inside, and we already have our curve solver set up. We just need to get the correct number of points now. And the way that we're going to do that is I'm going to get point transforms. Now this is circling back to what we were talking about earlier between the different singular and multiple. Since I know we want all the points of our simulated tail, all 4 of those points, and we want all the points of our skin tail, I'm going to use get point transforms. And I'm just going to have the first input, and I'm going to get all points just by using an asterisk there. And then I'm going to copy this node and change it to be the second input. So now we're getting all points of our tail node, or sorry, of our skin joints, all 12 of those guys. And we're also getting all 4 of our simulated / control joints as well. And we're going to take I'm going to rename these real quick. So these are going to be our skin joints. And these are our sim joints. So we want our sim joints to be those control joints. So we're going to hook up our out file into the control file and our points into the controls as such. And we know we want our skin joints to be the edited target joints here. So we're going to just hook things up as such as well. So it'll look like that. Now we just need to set those point transforms again. Whoops. So we're going to hit a set point transforms. Once again, multiple versus a singular point. And we're just going to hook up our points and our X forms like that. And if we take a look here and we start to play this, we can see that we have both of those joint chains following along this simulation now. So we have these 4 points being simulated, which are driving these 12 points. And we can come back and put a rig pose. Gosh, I'm losing my mind. A rig pose here to edit those 4 points and have a much easier time changing the simulated animation and having some nicer hand-drawn animation in there. And like covered in the first KineFX course, you can come in and keyframe these different poses if we wanted to. So we have it at let's say 0 to start. Here you can hit keyframe that, and then at 14 we want it there. Keyframe that, and you can start to have hand animation as well on top of your simulated animation. So you can start to get these multiple layers of simulation and KineFX animation or hand animation, all using joints and being able to utilize both KineFX joints and retargeting and that kind of stuff, and also still use simulation, such as this hair example. Yeah, that pretty much the extent of wrapping up this tail using these simulated points and using these driven points to have a nice kind of little complicated rig here. And once again, we have this little kind of useless point here that doesn't edit the curve at all and also kind of goes crazy as it is simulated, which doesn't affect our animation anymore at all, since we're using it as just a location for creating a curve versus one of the skin joints that we're using themselves. And of course, since this is a simulation as well, if it does kind of collide with the ground, which it doesn't quite, because Eric here is floating because I did a really bad motion capture just to start. But if the tail does collide with the ground, you can come in here and on your Vellum solver, you can add the I don't quite remember where ground plane is. Oh, there it is. You can put in a ground position and it will simulate with a ground position, and you can put in different collision geometry if that's what you want as well. And it'll all work very nicely together. Yeah, those were pretty much my examples that I had. Were there any questions regarding any of the 3 examples that we had? The one we just went over documentation for and video recording for, which is utilizing simulation and joints. Were there any questions regarding just cloth simulation on top of a deformed character geometry? Anything like that?
Yeah, and feel free to just open up your mics if you have them and chat, or you can actually throw them over questions. If you don't have a mic for some reason, you can throw it over into either the questions and answer panel or the chat, and I'll grab them from there as well.
Yeah, hey, this is great. Can this be used as well with KineFX? Or sorry, not with with crowd agents? Like, and then be layered in somehow?
That's a good question. I haven't messed with crowds too much previously.
As far as I know, the short answer to that is yes.
Yeah, it should work fine.
It's just a character rig, right? And you plug the rig into the agent, and once you've created the agent, then you're good to go. I would be, I'd be really curious to get into the weeds on it though. I haven't done the hard work on that to give you a like legitimate yes, I've done this answer. But I would assume if it works just like any other piece of crowds, you're just plugging a rig into an agent primitive, and once you've got your agent primitive. You just move forward from there, right?
Yeah.
Whether
Okay.
it's got antlers or a tail or a jacket or whatever on top of it, it would follow along with the agent primitive.
Yeah,
Right.
it should work perfectly fine for
And would
agents and
that be
crowds and stuff like that.
cached then, or would that be live at during a crowd simulation? Like, or I guess
Mm.
since you haven't tried it out, but yeah, that's kind of where my head is at with this. But if it's something that would be brought in like as an agent clip after like a definition cache, or sorry, before the definition cache, or could this also be live in crowds? But I guess we'll wait for another one of these sessions for crowds, maybe.
Yeah, that's probably a solid idea. I mean, seriously, to have another crowd session would be really good. Now that KineFX is out, that would be really solid. I will definitely put that on the list for our future schedule.
That'd be awesome. Thank you.
Yeah,
We can know
I think
I mean, right now, if I keep talking, I'm kind of just like spitting what I think might be the truth, but I
yeah,
know.
I
Right.
think so. If once again, I'm doing a similar thing to John, just spitting what I think is what would happen.
Oh, this is
But if
awesome.
you're
Thank you.
talking about having each individual character in a crowd simulation having their own, like let's say they each had their own tail and they were meaning to be reacting to the environment uh, each individually. I think that's what you're trying to ask,
Yes.
right? Yeah.
Or is that like not even, is that like crazy talk?
Well, I think that would require a unique uh, like hair simulation for each of those tails.
Yeah.
But what you can do is say you have that crowd, which is having a walk animation that is being grabbed from the agent or whatever. There are some videos out there already on YouTube that I can look up real quick where you can take crowd information and turn it back into KineFX information. So what you could do is if you had all these characters with tails, you could take the tail joints from all the crowds and then put them into a hair simulation or a cloth simulation. And then each of those tail joints would be acting independently to the character, specifically to their environment, versus having a cached simulated animation.
That would be really cool. If you can find me a link of what you're
Sure,
explaining
yeah.
there, that would be awesome.
Let me get back to you on that.
Sure. And
And
since
while
we're
I
on the topic of crazy talk, is
Yeah.
there, have you seen anything similar to this of, like the example that you had with the jacket, but for crowds as well with KineFX?
I have not seen jacket stuff anywhere really.
Okay.
Honest, not this specific example that I
There's one for sure I
Can-
know that
but-
Luca
yeah.
Irakia did, but I don't think he's using KineFX is the thing. He's just using regular old agents and he put Vellum on them. But he's got a really cool way of determining what gets simulated and what doesn't get simulated. And like he does some really cool tricks in that video, and I can find you a link to that. But again, it's not specifically KineFX. So
Okay.
but it's more crowds information, really cool, like simulation on crowds information that might help guide sort of your thought process on that.
Yeah. Well, KineFX is like crazy with crowds too now. Like it's just such a fantastic tool set. And so I think that, that all kind of goes together, and looking forward to where this is all going in the future too.
So here's I just posted in the chat the best. This is from 18.5 Hive, Be in Control Crowds and KineFX. He covers motion clip data and stuff like that. And then at the end, I think he takes some crowd information, turns it into KineFX, makes two characters hold hands and edits joints that way, and then turns it back into the crowd simulation. So there's some information there on how you can take a crowd information, turn it into KineFX, and start to edit joints there. And then you just combine basically that knowledge with this tail knowledge. And then
Did you put that in the
very
chat? No.
Yes, I think into the chat. Oh, I went to all panelists, my bad. There we go. All panelists and attendees.
Thank you so much.
I hope that's sent.
Yeah,
properly.
that's great. Thank you.
Okay. Yeah. I'm
Oh,
seeing
another.
something.
Oh, no, that was somebody was just asking for the links. Yeah.
Gotcha. Yeah. I do,
Any other
do
questions?
like a little
Or
sticker.
yeah.
I just so this is awesome. It's great to get the rundown. There's a little moment in how the solution to add the lower resolution curve and simulate that. The
Mhm.
thing I sort of know the instant question from students, and sort of the instant question that pops up in my mind is, but how is there a way, without sort of reinventing or going back to the drawing board, to actually simulate the high resolution tail and create the 4-point control rig? Because I sort of thought that's where we were going, because that's sort of but then you see the high resolution tail simulation, you say that's great, it'd be nice if it curled up even more. Is that back to the drawing board kind of thing? Because obviously we're losing some interest in motion from the simulation by only simulating 4 points. And I was just running through my head, like, how could I do that? And I wasn't, since I'm not familiar enough with these tools yet, I was, going and saying, oh, well, I have to start from scratch with this. But is there anything even potential that you could see?
Yes. Yes, there is. Okay. And I will do my best to explain it. I haven't tested it.
Yeah, but I know that's the classic, like, well, that's totally different. But
no, it's not too terribly and totally different. So
you're watching Houdini Improv 101 right now.
So. Exactly.
So let me just cut off this right about there. That's where I want it to be cut off. And I will change this to be back to 12. So we have our high res stuff. So that let me turn on our display. There we go. Proper stuff that we want. Okay, so now we have our high res simulation back as that. So what I would think of wanting, oh my gosh, I don't know what's going on with my computer right now. What I would think of trying to do is that after we have this simulation here, I would then probably make a delete joints, and I would select those 4 control joints that I want, like that, probably something like that. I almost evenly spaced it out. Oh well. And then I would probably delete non-selected, so that then we have oops, I didn't select my things for some reason. And sure, yeah, no, those that's 4 great. Points like that, sure, why not? So we got these 4 points now, and they are coming from the high res simulation. Look at that. Nice. And we want to then turn these guys into controls to control back our high res simulation here. So we can then probably do something very similar and take our taken joints, we'll call these the control joints or something like that, and we'll have our simulated joints, and then we have that output. Oh, but then that takes away the information again. Let me think.
Yeah, because then it's the classic, you almost get a double transform if you try to apply from one to the other. But can you, like, in that rig pose, it'd be great if is there a way to, like, create groups of, because that's sort of what you want, is to not have to do 12 individuals. The thought is you'd want sort of poses that affect group 1, group 2, group 3, because it has that option there. And would that be four joints instead of just 1 joint? Do you know what I mean?
Gotcha. Yeah. So in that case,
and I'm just guessing based on my understanding of the notes, not because I have any real depth of knowledge on it.
Yeah, this reminds me of a like a cheat, I guess, that I made in a rig for Maya one time, which could apply here. So essentially, when we take a look at um, let's just take a look. I know this is going to take away the simulation for a second, but when we take a look at this curve that's produced kind of thing, we're kind of just using these points here as somewhat editing the FK rotations of all these joints down the chain. It's a bit more elegant since it is a spline curve, but something that is possibly more strong arming it, if you will, is we can take these data here, this from our 4 points here, and we can have another rig pose here, why not, that our animators can't access per se, and we can this is the cheat and the strong arm that I'm thinking, is you can then take whatever, let's say all the points from tail 0 to wherever our next tail is, which is tail 4. So 0, 1, 2, and 3, you can have be controlled by the FK rotation. You can just have some channel references be put into these guys.
Totally makes sense.
So whenever you rotate this one joint, you're rotating all of the joints kind of down the chain. You might run into some other issues there. Like
no, that makes sense. I mean, that makes sense with what the rig pose is actually doing, is that it's just putting additional rotations on top of the joints that are already there. So
yeah,
I think, I definitely see the benefit of applying that spline to it, because that obviously smooths it out in nice interpolated ways. But, obviously this will give a different result. But if we wanted to say, could I add some sort of extra rotations to the joints that are the high resolution joints that are simulated? I think that totally gives me enough info to keep running with, just to be able to address that kind of a question.
Cool.
So that's great.
Yeah. All right. Nice. Are there any other questions? And at this point, it doesn't even have to be about cloth and Vellum and KineFX. If there's any questions in general or discussions that people have for one another.
I'd just like to say this was great. Thank you so much.
Yeah, thank you.
Yeah, somebody put that in the questions and answers, said the same thing, like excellent presentation. I was like, thanks, but it's not me, it's all Owen.
Thank you. Yeah. Well, if there are any other questions that pop up around KineFX in the next few days, in the next week or so, I will still be around to answer questions up through next week. You can email me
a few things if you are available.
Sure. Go for it.
So I saw that you're doing the blend skeletons thing. So is that's I guess a great way to the way you'd set it up to blend between a T pose and a I guess starting up a mocap sequence.
Yeah.
And is that generally like, so would you do that? Because right now I've been using rig stash poses for storing a T pose in.
Yeah.
But would you just be able to do this blend instead of that and then be done with it? Similar, like could that be a replacement instead of a rig stash pose?
Or what's your purpose of
for
using
retargeting?
For retargeting, I would still just use a stash node if you're talking about like right before retargeting, when you have the two nodes up here for the one that is the animation and one that's the rest pose. I'd probably just keep the retarget. It'll be or the rig stash pose. It'll probably be the easiest, especially if you have
a T pose or
if you have an animation that doesn't have a T pose, where it does load like most of the Maximo animations have no T pose as the first frame.
Right.
So it makes using these two nodes and the rig stash node an easier pipeline, since you're able to grab the rest pose from one animation import and the animation from the other one.
Okay. And would it
Um,
hurt to still have like a blend up top there, let's say on the left side of there, where the animation is to do this? So no, just right where you have the FX or FBX animation import too, right?
yeah.
Yeah. So like if I did I'm just curious, if I did a skeleton blend there up top to get into the pose, just so have it for Vellum, and then in addition to have the rest pose for, I guess, for
Gotcha.
whatever else, would that
So
be
I think you're
decent as well?
asking if you can have a skeleton blend right here about.
Yep.
Yeah. And you're asking if I could just blend from my character skeleton into that.
Right.
Yes.
Or T pose or anything, and then also have
Gotcha.
the stash pose. Is that an
So
ideal way to go about it, or would that cause any other issues?
that's a yes and a no, and I will show you why.
Okay.
So here's the yes and the no is
Okay.
that we can see we have let's see here, pose A and pose B. So we can see when we're scrubbing here, nothing is changing. One reason for that is that we're matching attribute by name by default. And since my character's skeleton here, if we just take a look at null over here, my character's skeleton looks like this, and the imported skeleton looks like that. And they all have different names as well. We can't
Okay.
just blend from this character skeleton to this imported animation. However, if your skeletons did match, say your institution or your studio had a character skeleton that is also the same as whatever your captured skeleton is,
Mhm.
then you could just blend because the names would be proper. You'd have the same skeleton setup. So the reason I personally have this, the blend after the retarget, there we go. The reason I have the blend after the retargeting is that once the retargeting is done, this output of this FBIK, the full body IK, is my character's skeleton following the imported animation.
Right.
So it's not the imported skeleton anymore. It's my
Same names.
characters. Yeah, it's the same names, same things like that. So theoretically, if you didn't have, if you had the same skeleton from importing and from your character, then yes, you could skip all of this retargeting nodes, all of these nodes that might be slowing things down or anything like that. And you could just go straight into a skeleton blend.
Okay.
So there's your yes and your no, and
Okay.
reasons why.
Thank you.
Yeah, absolutely.
I had a question as well. Just I know on the Slack, there's been some discussion about people starting to look at creating rigs and stuff in Houdini. And the thing that bubbled up in my head was the auto rig menu that's been around for a while. And obviously, or at least still my understanding, that doesn't use any of the new sort of KineFX stuff. And so this is obviously more of a big picture question, and I don't expect a solid answer, but is the thought that that would be rebuilt with KineFX is the main driving force for a animatable rig in Houdini?
Gotcha. Yeah, so I can't speak for the creator of the auto rig system, which is Michael Goldfarb here at SideFX. I do have the pleasure of working with him and working with him before joining SideFX as an intern. And from discussing with him, he and I don't, he is looking to update the system for KineFX. His ideology, I guess, that's probably not the right word, but his thought process is that the auto rig system is a very good starting point for those that just want to jump in and kind of create some quick rigs to test out different things and whatnot, but that the auto rig system produced by SideFX is not necessarily meant for professional use in, say, like a studio.
Right.
We're never going to change the auto rig system to meet individuals' certain needs.
Of
We're
course,
just going to
yeah.
use like a general auto rig system that helps any user build a system of joints and a skeleton, and then be able to mess around with that. So it won't have anything overly
That makes sense.
complex or anything like that. But
Yeah, it's more than,
yes,
I mean, it's obvious, you know, that the thought is to keep it in mind is that's all it's ever been, which is of course, you
Mhm.
know, head and shoulders above,
Right.
you know, most other things. And it's, you know, just like anybody who wants to auto rig something, they obviously don't have the time or the ability to rig it at a higher level. So yeah, that answers the question. And the thought is, as long as it's still, I was just wondering if it's still on the radar as, you know, something that would be updated with the new tools, but obviously not be, you know, expanded, you know, greatly in terms of its, you know, big picture functionality. But yeah, I just know when I tell people now, like, oh, you should check out the auto rig, they'd be like, oh, but it doesn't use KineFX, so it's old, you know, that kind of stuff. It's like, okay, well, you know, but it still does the job. But yeah, I think it would be good if it were updated, and I think that'd be great.
Yeah, I think Michael Goldfarb is looking to that for the future.
Right.
Mhm.
And I mean, it's probably pretty obvious to say, but I mean, yeah, KineFX, new tools, backporting is one thing, but new tools moving forward, everything will be centered around KineFX, right? We're not going to go back to object level rigging. Like that's not anything new that comes out, anything changes that will be made to future rigging tools and all that stuff will obviously all be ported around KineFX.
Great.
Very nice. Are there any other questions that anyone has? This has been great discussion.
Question about motion clips, and using, I guess doing this Vellum solve as well. How is there any different workflow that you would use if you had a set of motion clips as driving your animation after the retarget there, or would that just plug in directly into the constraints panel on the Vellum cloth there, or the input? Like if I had a bunch of retargeted animation or something like along those lines, I'm still trying to get my head wrapped around motion clips, and so I figured since I have you here, might as well see if I can pick your brain on this. But is that something like it's just giving me output animation, right? And it would be something, I'm assuming it would be similar to that, like the way I explained.
Yeah. So I think the let me see if I can pull up another file real quick from 11.1. The problem I think you might run into with just using motion clips is that if you plug a Vellum simulation / motion, if you try and combine Vellum and motion clips, you'll run into a problem since a motion clip is not technically moving. It's geometry that's all displayed at once.
Right.
At each frame, it's displaying it's like time in space versus space going through time.
Okay.
And let me see if I can explain that with this this video or this scene real quick. I'm getting a little warning here.
Yeah, the warning is that Einstein's not around for the theory of relativity.
Oh, cool. Okay.
Time in space versus space through time.
So I have some warnings from Maximo, which is fine. Let me see if I can. I don't have those animations on hand. Okay, but I can show some things, which I will just skip that. If you want to check out that scene, that is provided with 11.1.
I was just excited about that. Yes, I will.
Yes. So let me just take this information that we have here, and I'll move this stuff out of the way. And I'll probably just, I don't know, disconnect everything with the bone joint here. I'm just gonna mess up this scene real bad now. Okay. So we have our retargeted animation, and say we have in let's let me show you in this scene. So I have this Maximo. Let me switch this around real quick. Maximo, I don't know. Tomato. Anyhow, Mixamo animation, and that this is that stash node that I can't remember who was talking about it a second ago, but yeah, there's that stash node. And like I was saying, here we have our animation and our rest pose. And normally from a Mixamo animation, there's no T-pose, which is why this is a good pipeline for retargeting. And this scene and 11.1's course in general was kind of built like a scrapyard, I guess, taking animation from different points and retargeting them so that we can use our character that we built on our own and then editing things. So at some point we have a motion clip data here. And we take our different animations here. We have our Mixamo and our, or let's take this one. We have Mixamo going down this way and turning into motion clip. And we also have Henry's walk here, or a run. As we can see here, it's not running, that's fine. It goes down and eventually gets put into motion clips as well. And in motion clips, we can do some cool things. Like we can allow for cycling over and over again. Let me see if I can just put this directly into the motion clip versus this guy. And we'll see what, okay, there we go. Okay, perfect. Now I can kind of show what I'm hoping to show. Okay, so when we put an animation into a motion clip data, we can see that it gets displayed all together, all at once. And as we scrub through the timeline, nothing happens. Nothing changes. We're seeing time spread across space, if that makes sense. We're seeing frame 1, frame 2, frame 3, frame 4, in motion clip states, we can do different things. We can get rid of some poses. And in the course, we can see that he's on his left foot at the start, and I wanted him on his left foot at the end versus on his right foot so that there was a better cycle. So you can get rid of some frames. You can change the speed of things. Now that won't really change how things are displayed on the thing, in the viewport, but you can change how fast these frames come, these poses come, using motion clip retime. And you can change how many cycles there are. And in the course, I show that you can blend different animations together. This is like a running jump that comes in over here, and we can blend them together. So let's say we took this motion clip data here and we tried to plug in a Vellum simulation on top of that. That would probably not play very nice, but you can take it back out of motion clip data with this motion clip evaluate after you've done all of your motion clip editing that is special for motion clip areas, which is a good amount of blending and whatnot can be seen in that crowds video that was posted earlier. You can take it back out of motion clip data here, and it is struggling for a second, and I don't know why, but
yeah, they're really slow. Like just to evaluate it initially.
Yeah, it will give you the, oh, that's probably why I have a stupid, that's what was running it. You get your frames back out for your skeleton, and then you can put that into your bone deform and then go about doing the different claw simulations that were shown today.
Oh, perfect.
Be it
After the bone deform.
Yeah, be it
or
the jacket that I've destroyed now, or the cape. You wouldn't have to, you'd probably want, yeah, if you were doing the tail example as well, you'd want to do that outside of motion clips as well. Either you'd probably do it afterwards, so you get these nice cycles and loops and your different blended animations, and then you take it out of motion clip data, and then you take whatever joints or your tail or your, if you have antennas that you want or anything like that, you take those joints and then put them into your Vellum simulation and then pump it into your bone deform if your bone deform is built for the tail like if it's already part of the joint system kind of thing. Did that answer your question? Yeah.
Thank you so much.
Absolutely. And motion clips are more described in depth as well in 11.1. So definitely check out that course where we cover all of the blending and the editing of motion clips and whatnot. Yeah. Very nice.
I'll just jump in and say too, for anybody, let me look at our participants list again. I think most of you have been here prior and most of you are on Houdini Insight, but just for anybody that might be watching the video in the future, when Owen is referring to like 11.1 and 11.0, those courses are courses that are available on Houdini Insight, which is our portal specifically for trainers and educators. And if you need access to Houdini Insight, please contact education@sidefx.com. Or Sam can jump in with some other ways of getting hooked up as well. But yeah, just so for future reference, all those courses are available on Houdini Insight specifically.
Thank you, John. Sorry about that.
Yeah, no worries. Future proofing.
Wouldn't they be watching this on Houdini Insight in the future though?
Possibly, but there could be other like these videos could end up in other forms too, where people might not be.
Gotcha. Very nice. Well, are there any other questions? We're getting towards the end of time here, but we still got a few more minutes if anyone has any questions. Nice. Well, if any questions do come to mind in the near future, feel free to email me at onm@sidefx.com, I think is the email, I hope.
I'm pretty sure that's
Yeah, that's your email.
Yeah, thank you.
Owen
just
M
forgot
as
that.
in M as in Mark. So
Yeah.
Not Owen with two N's.
No, yes, thank you, Sam. Yeah. And I will be around for another week before I leave off to Sucker Punch. So feel free to email me. I'll be around for this week and next week.
You can also post your questions on the instructor Slack
Yep.
with that as well. And, you know, it's not like once Owen leaves, we can never answer any KineFX questions again.
Yep.
So, but now is an ideal time to get a hold of him and pick his brain because he's very, very well versed in this stuff. So, yeah, check the instructor Slack or send Owen an email or send me an email. Either way, we'll keep an eye on all those things so that we can answer questions in the future.
Yeah.
Awesome. Well, I think we can give everybody back about 3 or 4 minutes of their day here, and we'll call it good. But thank you, everybody, for being here today. This was a really excellent session. I really enjoyed the conversation. And thank you, Owen, so much for all of your hard work and research into KineFX. This has been great.
Thank you. And thank you, everyone, for coming.
Thank you so much. Good luck.